Okay, we're going to solve some inequalities with absolute values. These are, I think they're pretty fun. Uh, some people call me weird though. We're going to use a test point method to solve these. So we're gonna turn the inequality into an equation to find what I call critical values, cut a number line up at those critical values, and then start testing values between the critical values on the number line to find out which intervals make the inequality true. Let's go. Let's start pretty basic with the absolute value of 3x minus 1 is greater than 11. So we're trying to find the x values that we could plug in here to make the absolute value bigger than 11. And there are different approaches to doing this. I'm using a test point method in this particular video. To do that, I need to know my critical value. So I need to get 0 on one side, because now when I go to test, I'm just looking for where the left-hand side is positive, greater than 0, as opposed to greater than some arbitrary number like 11. To find the critical values, I need to solve the equation version of this. So the equation version would be the absolute value of 3x minus 1 equals 11. And if I want to know what to take the absolute value of to get 11, well, 3x minus 1 could be 11, but it could be negative 11. So 3x minus 1 could be plus or minus 11. So to get x by itself, let's add 1 and then divide by 3. So the critical values are 1 plus 11, which is 12, divided by 3, and 1 minus 11, which is negative 10 thirds. So we get two critical values. We need to see on our sign chart which intervals between these critical values make this inequality true. So I'm going to cut my sign chart at negative 10 thirds and 4 and keep track of what happens to the left-hand side of my inequality, because what I want is the left-hand side to be positive, greater than 0. Well, if I plug in negative 10 thirds or 4, I already know that the absolute value of 3x minus 1 will equal 11, meaning the left-hand side here will be 0. Now we're going to pick values in between those critical values for x and plug them in to see what happens to the left-hand side. Let's plug in positive 1,000 from the right side. I always like to choose extreme values on my left and right sides. Positive 1,000, well, 3 times 1,000 is a big number, minus 1 is still a big number. The absolute value of that, you get a positive big number. Minus 11, well, that's positive. If I plug in 0, which is between negative 10 thirds and 4, 3 times 0 is 0, minus 1 is negative 1. The absolute value of negative 1 is positive 1. 1 minus 11 is negative 10. So I get a negative here. And if I plug in negative 1,000, I get negative 3,000 minus 1, negative 3,001. Take the absolute value, that's positive 3,001. Minus 11 is positive. So I want to know where the left-hand side is greater than 0 or positive. So that's here and here. So the x values I'm looking for, the x values in those two intervals. Now, 0 is not greater than 0. So I'm not shading my endpoints here. They're not included because they don't make the inequality true. But everything in the intervals makes it true. So the solution is negative infinity to negative 10 thirds union 4 to infinity. Okay, let's try some more. Let's try 2 2 plus 3 times the absolute value of x minus 1 is less than or equal to, I don't know, let's say 16. So I'm going to go ahead and get 0 on one side. So I'll subtract 16, which gives me negative 14, plus 3 times the absolute value of x minus 1 is less than or equal to 0. And now we've got the left-hand side for our sign chart, but we need the critical values. So I'm going to look at the equation version of this and start to isolate the absolute value. So the first thing I'll do is add 14, and then I'll divide by 3. So the absolute value of x minus 1 equals positive 14 divided by 3, so 14 thirds. And the absolute value of something is 14 thirds if what's inside the absolute value is plus or minus 14 thirds. Now we can get x by itself because we don't have those absolute value walls. We're free to get x by itself by adding 1 to both sides. So our critical values are 1 plus 14 thirds is 17 thirds, and 1 minus 14 thirds is negative 11 thirds. So let's look at our sign chart. Negative 11 thirds is to the left. Positive 17 thirds is to the right. And we already know that if we use either of those critical values, then the expression on the left-hand side equals 0. And now we just need some test points. Let's plug in 0 first between negative 11 thirds and 17 thirds. 0 minus 1 is negative 1. The absolute value of that is positive 1. Positive 1 times 3 is 3. Minus 14 is negative. If we plug in positive 1,000, we get negative 14 plus a really big number, so that's going to give us a positive. If we plug in negative 1,000, we get negative 14 plus a really big positive number again, so that's positive as well. And now we want to know where the left-hand side is less than or equal to 0. So it's equal to 0 here, less than 0 there, equal to 0 here. So we're going to shade those endpoints and everything between. And we just have one interval from negative 11 thirds to 17 thirds, including those endpoints. And that is how you solve absolute value inequalities. I suppose I should mention a couple things. And let's do one more example. Sorry, I got a little ahead of myself there. Okay, let's do something like 4 minus the absolute value of x plus 3 is less than 9. And so let's go ahead and get 0 on one side. So we have 4 minus the absolute, sorry, I need to subtract 9 from my 4 to give us negative 5, minus the absolute value of x plus 3 is less than 0. Now let's go find the critical values by solving the equation. So to get the absolute value by itself, I'll add 5 over first. And then I'll divide by negative 1. And what can you take the absolute value of to get negative 5? Nothing. So there are no critical values in this problem. That's why I want to do this one last example to show you what happens. That doesn't mean you can't try to solve the problem. It just means that you can't cut the number line anywhere. You simply pick one test point, right? There aren't multiple intervals here. It's one interval, the whole number line. And so we might test 0 in the left-hand side. Well, 0 plus 3 is 3. Negative 5 minus 3 is negative. So the entire left-hand side is negative. No matter what you plug in for x on the number line, the left-hand side's going to be negative. And we're interested in where it's negative. So we have to shade all of the number line for our solution. And my handwriting program thinks I want to delete that by scribbling on it. So the solution here is negative infinity to infinity. So that's kind of odd, right? There were no critical values. So we look at the entire number line. You either shade the whole thing or you shade none of it. So if this would have been greater than 0 and the left-hand side was always negative, we wouldn't shade anything on the number line, and we would say there is no solution to this inequality. It'd be impossible to make it true. But in this case, everything makes it true. So that's kind of odd. Thought I'd throw that in there for you.